Good afternoon, Algebra, periods 1, 6, and 7. We're still having some difficulty graphing a parabola, so I'm going to put an example on the board that highlights a basic quadratic function, a basic f of x is equal to ax squared plus bx plus c. We're going to find those 5 points that we need to graph it, and we're going to graph it. First, I'm going to go through just a general demonstration, and then we'll do an example and we'll actually graph it. So here we go. So there's your quadratic form. F of x is equal to ax squared plus bx plus c. To graph a parabola, we need 5 points. All right? So the first thing we're going to do, we're going to identify the coefficient in front of the x squared term. That's a. We're going to identify the coefficient in front of the x term. That's b. And then c is just hanging on the end. We're going to find out we need that too. So to find the 5 points that I need, the first step is to find the axis of symmetry. And this is the equation to find the axis of symmetry. You need to know this. You take your b, and whatever it is, you take the opposite of it. If it's a positive, now it's negative. If it's negative, it's now positive. And you divide that by 2 times a. Step 2, we need to find the vertex. Remember, if it opens up, the vertex is the lowest point. If it opens down, the vertex is the highest point or the maximum, and if it opens up, the vertex is a minimum. Now, the vertex is on the axis of symmetry, so we already know once we find that x is the x value of the vertex. Then we need to find the y value of the vertex. So we just need to plug the x in, and that will give us the vertex. And then, of course, we can find the axis of y-axis intercept. That's going to be c. If you put a 0 in for x, that's all you got left. All that turns into a 0. So that's your y-axis intercept. Okay? So now we have a axis of symmetry, we have a vertex, we have a y-axis intercept, we need to find the x-intercept. To find that, we need to factor it. Okay? And we have lots of ways to factor it. If you can't factor it, then plug in some integer values for x and get a couple of y's. Okay? And remember, parabolas are symmetric. If you find one on one side of the axis of symmetry, there's going to be one on the other side. All right, so here's the example. X squared plus 6x plus 8 is equal to f of x. Identify a, b, and c. A is 1, b is 6, and c is 8. So the axis of symmetry, x is equal to negative b over 2a. Negative b, negative 6 over 2 times 1. Negative 6 halves, or the axis of symmetry is negative 3. So I came over here and I sketched my axis of symmetry at x is equal to negative 3. That's the first thing I did. I went up to my graph paper and I sketched my axis of symmetry. To find the vertex, you know the x value is negative 3. Take the negative 3, plug it into your equation. Negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is 9. Minus 18 plus 8 is negative 1. So there is my vertex. So I came over here and I plotted my vertex. I put it on the paper. There it is. Okay? Vertex. All right? Now I need the y-axis intercept. Put a 0 in for x. 0 squared is 0. 6 times 0 is 0. And all you got left is the 8. There's your y-axis intercept. So I came over here and I plotted my y-axis intercept. 0, 8. Now, notice that this is 3 units to the right of the axis of symmetry. So I went over 3 units to the left of the axis of symmetry, and I put a dot. I reflected it. There it is. Okay? So now I have a vertex, and I have a y-axis intercept, and I have its reflection. I need 2 more points. So, to factor this, remember, set it equal to 0 and solve. So I need factors of 8 that add to 6. Well, that looks like that. How about 4 times 2 is 8 and 4 plus 2 is 6? Then set each individual factor equal to 0, each individual factor equal to 0, and you'll find that x is equal to 4 and x is equal to negative 2. Well, if x is equal to negative 4 and x is equal to negative 2, now I have 1 point, 2 point, 3 point, 4 point, I have 5 points. And then I connect them with the smoothest curve that I can muster, and there it is. My beautiful parabola. Labeled axis of symmetry, vertex, x-axis intercepts, y-axis intercepts, and a reflected point. Notice that those two x-axis intercepts are also reflections of each other through the axis of symmetry. It's the darndest thing. All right, so there's a parabola. We graphed it. I hope that helps.